Yeah, hi dear Payam, dear Professor Payam, good evening. So today I'm going to explain Python programming assessment assignment 1002, that is like closest planet. So for this we have prepared one final report. So this is like a top-down structure chart of the planetary distance simulation. So this one is a planetary distance simulation. We are dividing into initialization, daily operations, data collection, and analysis and assumptions. So for this, like initialization is like this is the starting phase where the simulation defines the planetary information, including the arbitrarily radiant periods of the planets involved. These parameters are essential for the accurate calculation of the planetary positions with their orbits. And daily operations is during the phase the simulation executes on a loop representing each day of the 1000th. For each iteration is a calculated position subroutine computes and coordinates of Mercury, Venus, Earth, and Mars of their respective orbital paths. So following this, calculating distances like subroutine computes the distance between each pair of planets based on the calculated positions. So data collection is as the simulation progresses, each calculated distance is stored in a structured format, especially as data frame. This facilitates easy access and manipulation of the data of subsequent analysis. And analysis like and assumptions. So planetary orbits are assumed to be circular of simplicity. This is a common simplification that enables easier computation while introducing a negligible error for the purpose of the simulation. And heat map of the average interplanetary distance. So here like average distance between the planets over 1000 years and Mercury, Venus, Earth on the same like where average distance millions miles. So where x-axis and y-axis is the heat map provides visual representation of the average distance between each pair of planets in the solar system over the course of simulated 1000 years. So the key insights is like the diagonal representing the distance of each planet itself is correctly set to 0 as expected. The symmetry of the matrix reflects the fact that the distance from the planet A to planet B is the same as from the planet B to planet A. The shorter average distance indicated by the darker shades. So output image like the A28 chart visualize the average distance between all pairs of planets over 1000 years. The third one is like proximity analysis and comparison with expectations and result. The simulation collaboration of Venus and its closest planetary neighbor does more than just validate common astronomical knowledge. So it serves as a benchmark for the model accuracy. The fourth one is like distance from the Earth to Mercury, Venus, and Mars over 1000 days. So output image like this time series charts displays the distance from Earth to Mercury, Venus, and Mars over a period of 1000 days. So each line represents the facilitating distance between Earth and the respective planet. Apart from this, like we are using extending the simulations can enrich its accuracy, realism, and educational value. Here are the three ways could expand upon the current simulation of the planetary distances. One is like incorporate elliptical orbits. Another one is model gravitational interactions, and another one is like implementing these extensions. So including more celestial objects. So appendices. So finally, simulation that runs for 1000 years. We have take the packages like an MPS, NPN, Pandas as PDs or Matplotlib, PyPlot as PLT. So define planet class and define simulation class and define calculate distances and create instance of planet class as well. And create list of planets and calculate average distances, all these things, and plot average distance heat map as well. So yeah, thank you so much for giving me this opportunity, dear Professor Prime sir.